This video is on Unit 10, Lessons 10 and 11. So Lesson 10 deals with polynomial long division. So before we begin with polynomial long division, we're going to go over how to just do long division with numbers. So when you're doing long division with numbers, we usually set it up in this way. The number you are dividing by goes out in front, and then the number you are dividing into goes underneath this little divisor symbol, like so. Then you're going to start by asking yourself, does 7 go into the number 1? No, it does not. It does not divide into 1. So therefore, I'm going to look at the first two numbers. 7 goes into 15 how many times? It goes into 15 twice. So I'm going to put the 2 above the 5 since I'm putting that into the first two numbers. 7 goes into 15 twice. 2 times 7 is 14. So that goes underneath 15. Then you subtract those two numbers. 15 minus 14 is 1. Then you bring down the very next number, which is another 1. 7 goes into 11 one time. 7 times 1 is 7. Then you subtract 11 minus 7 is 4. And you keep bringing down the numbers until you've brought all of them down. So this is the last number. So it's 49. 7 goes into 49 7 times. 7 times 7 is 49. When I subtract those out, I get a remainder of 0. Remember, if there actually was a remainder other than 0, it would go, you can either write it as a fraction. So if the remainder were like 2, you would write 2 over this number 7. Or sometimes kids write it like remainder 2, but usually we do write it as a fraction with whatever the remainder is over whatever we were dividing by. Okay, so to do it with polynomials, this is where x's or whatever variable they choose to use for that particular question comes into play. So again, you're going to set it up the same way. So outside is x plus 6, and underneath is 2x squared plus 15x plus 18. I actually find this to be a little easier than long division with numbers. All you have to do to get your first number in your answer is ask yourself, what would I have to multiply x by to get 2x squared? Well, you would have to multiply it by not only 2, but 2x. Now you multiply whatever you put up here by what's out in front, and you put that answer underneath, and then you're going to subtract down and then start over. So 2x times x is 2x squared. You always want like the first term to cancel out when you're subtracting down. So that will cancel out, and then 2x times 6 is 12x. Now when I subtract down, you'll notice the first terms do go away, but 15x minus 12x is 3x. Bring down the 18, the plus 18, and now you start the process over. What would I have to multiply x by to get 3x? Because you always want the first thing that you subtract to go away. So x times 3, positive 3, would get you 3x. So now you just have to multiply everything out in front by that number 3. So 3 times x is 3x. 6 times 3 is 18. Something nice is going to happen when you subtract down. It actually turns out to be a remainder of 0. So your answer, when you divide those two polynomials out, is 2x plus 3. Now to check if you did it right, and I should have actually showed you the check over here with numbers, you should be able to multiply your answer with what you were dividing by and get that starting number that was underneath. So again, you should be able to multiply 2x plus 3 by x plus 6. So you would do 2x plus 3, and you would do your double distribute times x plus 6. If you don't get 2x squared plus 15x plus 18 when you're done, that means you made a mistake somewhere. So go back and try to find it. Okay, the last one, we are taking x plus 3 is the guy that's doing the dividing, and x plus 8 is who are we dividing into. Well, again, you start by asking yourself, what would I have to multiply x by to get x? Well, you'd have to multiply by 1. If you now multiply everything out in front by 1 and put it underneath, that's x plus 3. Now subtract down. The x's go away, but 8 minus 3 is 5. You cannot multiply x by anything to turn it into 5, so that is when you know you are done. 5 is your remainder. So to write your final answer, here's how you would write it. So x plus 8 divided by x plus 3 turns out to be 1 with a remainder of 5 over, we were dividing by x plus 3. Okay, so it's 1 and 5 over x plus 3's. So that is it for that lesson, lesson 10. So now we're going to go on to lesson 11, which also has to do with division. Lesson 11, though, deals with the remainder theorem. And this is an interesting theorem that will make your life a little easier when asked certain questions. So let's make sure we understand what the remainder theorem is. The remainder theorem says when a polynomial, any polynomial, is being divided by a linear factor of this form, so it has to be in the form x minus a, okay? If it is in that form, then you can figure out what the remainder will be without even having to actually do the division. And here's how you figure out what the remainder will be. Everybody put an arrow next to P of A. That's your remainder. So if I wanted to know what the remainder would be in any polynomial, I simply plug in whatever this number is. Now be careful because it has to be in the x minus form. So if it's in an x plus form, so if it looks like this, x plus a, that's otherwise known as x minus a negative a. So be careful because if it's in the plus a or plus, that'll be a number. So if it were like x plus 3, a is actually negative 3 in that case. If it were x minus 3, a is actually 3 in that case. So it has to be x minus and then that number is your a. So be careful because if it's a plus, it was actually a minus, a negative, so your a is going to be a negative number. So if you just kind of tell yourself the trick is it's always the opposite of what it looks like. So this looks like x minus 3. Well, it is x minus 3, but I'm actually going to use positive 3. If it's plus 3, I'm actually going to use negative 3. So what this says, back to what I was trying to say this whole theorem says, is that if you plug in that number into your polynomial, whatever the top is, then whatever you get for your answer is what the remainder will be. So let's take a look at this first example. They want to know what is P of 2. Well, before we actually find P of 2, let's do this division out so you can see the relationship. So let's practice division again. Let's divide x minus 2 into x squared minus 8x plus 18, just so you can see the connection. So really quickly, x times what is x squared? Well, that's x. Now if I multiply the outside by x, I get x squared minus 2x. If I subtract down, the x squareds go away. Negative 8 minus a negative 2. Be careful because it's a double negative, so that's really plus. So negative 8 plus 2 is negative 6x. Bring down the 18. What do I have to multiply x by to get negative 6x? Well, that would be a negative 6. So negative 6 times x is negative 6x. Negative 6 times negative 2 is positive 12. When I subtract down, be careful because this is a negative 6 minus a negative, so that turns into plus, which is 0. But then 18 minus 12 is 6. So 6 is my remainder. Well, now let's take a look at if we plug in the number 2, and I'm choosing 2 on purpose because 2 is my a up here in the remainder theorem. It's the number that is next to the x minus on the bottom. So let's plug in 2. So P of 2 into my top of my, what I'm dividing into, that's your P of x, right? P of x is only what's on top. So I'm going to plug in 2 into the top. So that's 2 squared minus 8 times 2 plus 18. Well, if you evaluate that, that's 4 minus 16 plus 18. So 18 minus 16 is 2 plus 4 is 6. oh, wait a minute, look at that. The remainder, when I actually did the division, was 6. So if you are asked, like in the next one, I don't care what I actually get when I divide x squared minus 11x plus 22 by x minus 9. The question simply asks, what's the remainder going to be? So you don't want to sit there and actually have to do, you can divide it out and find the remainder. Or if you know this theorem, you know that the remainder is going to be whatever you get when you plug in a into the top of that fraction. So a in this case, write down a is 9 because I am dividing by x minus 9. So if I plug in 9 into the top, into x squared, so 9 squared minus 11 times 9 plus 22. So 9 squared is 81. 11 times 9 is 99 plus 22. So 81 minus 99 plus 22 is 4. So the remainder is 4. That's your R. And that's it. So you answered the question without even having to divide it out. Now, if you forget this theorem, no big deal. You can just actually do the division. It's a little more work, but you will be able to find the remainder that way as well. And the last example, it says, is x minus 3 a factor of this polynomial? Well, you could divide it out and see if it actually is a factor or not. To tell if it is a factor, what you're looking for is the remainder will be 0. You won't have a remainder if it truly is a factor. If the remainder is not 0, then it's not a factor. So to tell if something is a factor or not, you would divide it into your polynomial, and if you get no remainder, then it is a factor. If you get a remainder, that means it wouldn't factor into this. Like if you could probably actually factor this in your head using 1am and determine if this is a factor or not. But to tell with division, you would divide this into the p of x and see if you get a remainder. Well, we could use the remainder theorem as well. If we plug in 3 for a and we get 0, that means the remainder would be 0, which means it is a factor. If we don't get 0, then that means that it's not a factor. So let's plug in 3. So that's 3 squared minus 11 times 3 plus 24. So that's 9 minus 33 plus 24, that is 0. So you would say, yes, x minus 3 is a factor. If you plug in your a and you don't get 0, then you would say, no, it is not a factor. Or you could divide x minus 3 into x squared minus 11x plus 24 and see what the remainder is that way as well. If it is 0, you say, yes, it is a factor. If it is not 0, it is not a factor. Because if you think about what a remainder means, if there is no remainder, that means, to use a non-mathematical phrase, it means it divides into it nicely, right? There's nothing left over. It divides into it cleanly, I guess you could say as well, a non-mathematical phrase. But if there is a remainder, that means it doesn't divide in nicely or cleanly, or I don't know, it just doesn't divide in with no remainder, so that means it's not a factor. If there, or with a remainder. If there is no remainder, it is a factor. Okay, and that is it for this video.